How y'all doing today? I'm Andrew Glaser. Today I'd like to teach you how to find the intercepts and the asymptotes of this rational function of x plus 2 squared times x minus 5 all over this whole bunch of mumbo jumbo. So how do we do this? Well, in order to sketch the graph, we need to really understand two important things. We have to understand where the intercepts are, meaning the x and the y intercepts, and we also have to understand where the asymptotes are. So we're going to look at each of these individually. So first, there's two types of intercepts, right? There's an x-intercept, and then there's a y-intercept. And I might have said that in the singular, but it can be plural. In other words, we can have several x-intercepts. Hopefully we only have one y-intercept, otherwise that might violate this is not a rational function, it won't be a function anymore. But pretend this is the graph, and the x-intercepts are where the function crosses the x-axis, and the y-intercept is where the function crosses the y-intercept. You have x values here for your x-intercept, and then you'll have a y value for your y-intercept. All right. Now, it turns out that there is something unique about the x values, or the x-intercepts, is that you will have some number there for x, but the y value is 0. Right? So we know that the x is going to be some value, but the y value will be 0. For your y-intercept, then, you have the opposite. You know that the x value is 0, but then the y is some number. So that should help drive now how we're going to approach how to find the intercepts. For example, if we have this function, simply rewrite it. I'm going to write it as y is equal to x plus 2 squared times x minus 5, all then being divided by, this is x plus 3. No, don't make a silly mistake like that, huh? Are you paying attention? Times x plus 1, I was just checking to see, times then x plus 4. Now let me just double check myself, and everything looks good. All right. So what we're going to do to find the x-intercepts, like we said, with all the x-intercepts, there's something unique, is that the y value is 0. Okay? So take this y, erase, and make it 0. Now what's going to happen is that basically anything in the denominator will cancel, because when you solve this thing, you're going to do a cross multiplication, and 0 times anything down here is going to be 0. Right? So in other words, you can almost just simply take the numerator, whatever in that numerator, and set it equal to 0. All right, to find your x-intercepts. So we got x plus 2 squared times an x minus 5. Now, how do we solve something like this? So what we're going to do is we kind of notice that we have two unique terms. We have this x plus 2 squared term and this x minus 5 term. So what we do is we set them both equal to 0 in order to solve this. Why is that the case? Well, because if this thing is 0, then 0 times whatever the heck this might be is 0. And vice versa, if this whole term is 0, then that multiplied by whatever the heck this thing would be 0. All right, so we're trying to find those x values that are 0. You might even notice, how to do that. Right, what should x be here in order to make this thing go to 0? Right, you're probably already, minus 2. Yeah, precisely. Right, so the way to do that now with math, all right, is to set it equal to 0, because that's what I'm looking to do. So set that equal to 0. Then you're like, oh, this is squared, so I got to take the square root. Sure, you take the square root of both sides, and what that'll do is it will get rid of the square there on the left-hand side, and then the square root of 0 is just 0. And now you can solve this, right? I'll get rid of those parentheses for us over there. So let's get rid of them, okay? And then how do we do that? We subtract the 2 from each side, right? And x is going to be equal to negative 2. And that's what you thought intuitively. You see? Not bad. Same thing here. You're going to take that, set it equals 0. You probably already noticed what x value would make this thing become 0. Right? And you're like, oh, that should just be x is equal to 5. So that's right. These are the x values now of the x-intercepts. Isn't that cool? So we got two of them. We're going to have a negative 2, comma 0, because remember the y value is 0. So negative 2, comma 0. And we're also going to have 5, comma 0. Cool. Now, how do we do the y-intercepts? Well, if to find the x-intercepts, we made the y value equal to 0, well, the y-intercept's just the opposite now, right? The x value is equal to 0. So what you're going to do, you're going to have your original y here, and everywhere now in this function that you have an x, you're going to plug in 0 for it, okay? So let's just save a little time. I'll just erase the x's and just simply plug in zeros there. right? If this is 0 and that's 0 and 0 and 0 and 0, it's almost like, you know, you can almost just cancel them fully, right? It's just now going to be y, meaning you don't even need to put it in, right? So it's going to be 2 squared times then negative 5 all over negative 3 times then 1 times then 4. And now we can calculate this, right? 2 squared is going to be 4. 4 times negative 5 is going to be a negative 20. All being then divided by, on the bottom, that's going to work out to be a negative 12. Right? And then you can reduce this. I don't know if you need it in a fractional form, you can put it in a decimal. Doesn't really matter. But if you want, use your calculator. Do negative 20 divided by negative 12. And bada bing, bada boom, it's a positive 1.6. All right? So I'll just leave it in decimal form for right now. 1.6 repeating. And we're good to go. Now that's the y coordinate. Okay? So, let me just erase this. Actually, we'll just minimize it. So now what we're going to do is I'm just going to plug that in here for the y-intercept. So the x value is 0, and the y value we found is going to be 1.6 repeating. So those are the intercepts. All right? Now, asymptotes. How are we going to find them? So we have a few different types. We have 2 main categories. Okay, we have vertical asymptotes, 2 main categories in terms of how to solve for them. But we technically have 3 types of asymptotes. We have vertical asymptotes, and then we have something known as horizontal asymptotes and slant asymptotes. The way we analyze which one we have is going to be similar for horizontal and, actually not similar, but the same. All right, the way we then approach it afterwards might change. But I break it up into 2 main categories first. First, let me find the vertical. Then let me figure out whether we have horizontal or slant. And then if it's horizontal, there's one way to do it. If it's slant, there's another way. So in terms of vertical asymptotes, all you're going to do to find the vertical asymptotes is you take your denominator and you set that bad boy equal to 0. All right? And the reason for that now is, one second, let me just make sure I write that down right, because I notice most of the silly mistakes I make are while I'm speaking. Brain can't really do too many things at once. I'm trying to remember, there was a book. I forgot the name of the book. Well, what was the name of the book? Oh, right. The name of the book was The Myth of Multitasking. So it was a good book. Kind of a myth. You can't really multitask too much, even though most of us think we can. We can't solve a complex mathematical problem at the same time having a conversation. We just can't do it. There's certain things we can automate, like you can chew gum and have a conversation. But there's other more mentally intense tasks that we cannot. So good book if you'd like to take a read. I know you're like, read? I'm busy doing math. I don't have any time to do any leisurely reading. And if I were to leisurely read, you think I would read The Myth of Multitasking, Andrew? All right, point well taken. So back to the vertical asymptote here. What we're going to do is we take that denominator set equals 0. And the reason being is because anytime this denominator is 0, all right, it's going to produce a weird result, right? It produces an undefined result. Let's say, what's 4 divided by 0? It's, I don't know, undefined, right? We can't divide 0 into 4. How many times does nothing fit into something? I don't know, it's nothing, right? So that's the idea. That's where the vertical asymptotes are going to lie. So we approach this the same way as we did before. We have 3 unique terms here. We set them each equal to 0 to solve that. Okay, but doing this quickly, you can already see what x value causes this to go to 0, right? A positive 3. So x is going to be positive 3. How about this one, right? X is going to be negative 1. And then how about this one? The x value should be a negative 4. So we technically have now 3 vertical asymptotes, okay, at each of these x values. Remember, anytime you have a vertical line, it's always going to be x equaling something, all right? So that takes care of that. Now we're going to do horizontal slant. And if I could speak, that would be nice, right? Let's try that again. In order to figure out whether you have a horizontal asymptote or a slant asymptote, you want to identify whether you have a top-heavy function, an equally heavy function, or a bottom-heavy function. So what I mean by that is your overall function, I want to identify the highest power of x in the numerator and the highest power of x in the denominator. Now for this, you really don't want it in factored form. So this is in factored form. Okay, what we would have to do is we would kind of have to unfactor it, right? We'd have to distribute, so to speak. But thinking about this quickly, Remember, this is x plus 2 squared, so it's almost like if you didn't have the square there, you would have another x plus 2 term, okay? And then you would take, the x times the x and then times the x eventually. So you'd have x cubed on the top. That would be the highest power of x in the numerator, okay? Same thing goes for that denominator. The highest power of x after you do that distribution is going to be an x cubed, all right? So whenever you have the same power, or same degree, I should say, in the numerator and denominator, that's known as an equally heavy function, okay? Anytime you have an equally heavy function, you're going to have a horizontal asymptote, all right? Not a slant asymptote. And it turns out also if you have a bottom heavy function, that's also a horizontal asymptote. The only time you're going to have a slant is when you have a top heavy function. Now, if you have a top heavy function, in order to find the slant asymptote, you have to do a long division. I have some videos on that. Check out the playlist, a couple of prior problems, all right? But in this one, it's going to be horizontal because it's an equally heavy function. Now, in order to find the the horizontal asymptote, all you're going to do is take the coefficients of those highest powers, which is both 1, and you divide them. So obviously 1 divided by 1 is simply equal to 1. Now that will be then the value of the horizontal asymptote. Now since it's a horizontal asymptote, all horizontal lines have a y value equaling something. So this is y equals 1. All right. Now we have everything we need in order to graph this thing. So let's take a look now. Let's try to graph this. All right, let's try to do this as best we possibly can. So I'm going to maybe off-put this a little bit, just looking at some of the values that we got. All right, so maybe I'll just draw this over here. Now let's start plugging in our x-intercepts. So I got it at -2, so -2, 0. I have it also at 5, 1, 2, 3, 4, 5. And I have a y-intercept at 0, 1.6. So maybe that's roughly around here. Okay, so that's good. Now let's plug in our vertical asymptote. So it says x is equal to 3. So you got to go to x being 3, draw your vertical line. All right. And I'm going to dash it for now, just so we don't get confused that it's just an asymptote there. All right, so now we're going to place another vertical asymptote at x being equal to -1. So that should be somewhere over here. All right. And then x is going to be equal to -4. So somewhere, oh boy. Did I kind of mess this up a little bit? Something like that, right? Not that I messed it up. I didn't really leave much space. And the last one now, what we're going to do is we're going to put in then that horizontal asymptote at y equals 1. So we're going to draw another little line like this. All right. So now what we need to do is we need to figure out how to draw this thing. So what you want to do is you want to look into see how many columns, all right, we actually broke this thing up into. So what I'm going to do is I'm actually just going to shift this stuff ever so slightly this way, just for a moment, because I need a little bit more space over here. All right. So now, yes, ignore. So now what I want to do is, as I mentioned, I want to look at this as now I've broken this up into columns. All right. I have one column over here, all right, one column over here, one column over here, one column over here. Each of those columns was then broken up into 2 halves, right? There's 1 half up here and then 1 half down here. So the important thing is now that you have to figure out where the function is in each of those columns. Is it on the top or is it on the bottom? Is it on the top here or is it on the bottom? Is it on the top or the bottom, etc.? Okay. Now there's one column here that's a little bit rough. I don't know, right? I don't have any point in here to kind of work off of. I definitely have a point here, I have a point here, and I have a point there. So that's easy. So I know that, like, in terms of this column, there's no function up here. The function is only going to be down here. You cannot have the function up here and down here because guess what? It's not a function anymore. It violates that vertical line test. All right? So this is going to look something. Now, to draw something like this gets a little bit icky, okay, in terms of this. But what you want to do is you want to try to sketch this to the best of your ability, okay? So what we're going to do here is we know that, let's say in this region, it's going to cross this x-axis, but we have these kind of bounds on either side. So what'll probably wind up happening is this thing's going to come up, all right? This thing is going to come up and then come back down at some point. It's not going to make a sharp point, so it'll be some type of continuous curve here. And I'm going to try to do my best. You know, it'll look something-ish like that-ish, okay? It's It's going to have that kind of setup to it. Same thing now in the third column over here. We know that the function is going to be up here. I'm going to try to make that setup a little bit nicer. So let's just make that adjustment over here. We'll try to adjust this as best as possible. And you know what? It's not really going to work. It's not really going to work. So I have to freehand it, okay? So let's cut this out, and we're just going to freehand this. So it'll look something like this, all right? And then same thing over here. Now you can't cross these bounds. These are the asymptotes, so it's going to come up and go all the way on out like that forever. Now there's only one location, one column that we didn't take into account. It's this one. Where's it going to be? We don't know. So the best thing to do is to now choose an x value that's in this region. So it's -1, -2, -3, -4, -5. So why don't we take a look at when x is -5 now? When it's -5, what's the function doing? So what you can simply do is plug that into your formula, all right? You can say that if x is going to be -5, so let me just go back and erase this because we'll look at the original function overall, even though they're equivalent. So this is -5, this is going to be -5, -5, -5, -5. Right, so this whole term becomes a -3, but that's squared, so that's going to be a 9. Then this is a -5 minus 5, that's going to be a -10. Okay, so that looks like it's going to be a -90. I don't know why that took me so long. And then this one's now going to be a -8. This is going to now be a -4. And then this is now going to be a -1. So then we can multiply all this together, and we're going to get the -32. So now it's basically, that's going to be -32 on the bottom. All right, so it's -90 over -32. I don't really even need to figure that out technically, but that'll be a little bit smaller than 3. I think it'll be positive, 2.8-ish, something like that. I don't know. But 2.8, the important thing is that what I realize now is that when x is now going to be -5, the value is going to be about 2.6. So I know this is now my point. This is my point. So I know the function is then up here, all right? And the function has to asymptotically approach both of those asymptotes. So that's kind of the picture. To double check, what you can do is you can go to your calculator then. You go to your y equals and plug in the function. All right, so we'll do x plus 2 squared times then x minus 5. Be careful with your parentheses, especially when you plug this in. I'm using a double parenthesis because I am trying to keep the numerator separate from the denominator, okay? So there's going to be x minus 3, and then times x plus 1, so x plus 1, and then times x plus 4. All right, and let's graph it. Let's see what happens. And boom, there it is. All right, so as you can see, this function looks identical to what we have over here. Okay, and you can also see that asymptote right around y equaling 1. You can also go back. You can even plug that in for 1, and you can see that 1, that horizontal asymptote. You can't really graph the vertical asymptotes in this calculator very easily because they're not functions. But, hopefully that makes sense. Guys, thank you very much for tuning in. I really do appreciate it. I do hope this video helped, and if it did, help us out. Like, subscribe, maybe you can tell some of your friends or classmates, and we'd love to help you with more stuff. Check out our channel because we have thousands of videos. Look forward to helping you with more. Take care.